Hello, YouTube! Are you looking to install your first Home Assistant server? Maybe you already have a Home Assistant instance, but you've outgrown the current hardware and you're looking to upgrade? Have you been reading Reddit posts and Facebook group posts and Home Assistant documentation about the different types of installation methods and it's making your head spin? In this episode, I'm going to cover the different types of deployments, the pros and cons of each type of installation, as well as the pros and cons of the various ways to run them. There's a lot of information to cover in today's topic, so this video will be a bit longer than my usual videos. I'll do my best to edit it as tight as I can, so any content you're watching will be informative. Please stick around to the end as I do my best to answer all the questions I've gotten from viewers, as well as provide more in-depth info to help you figure out which Home Assistant installation model is best for you. My name's Jeff. Welcome to the channel. I'm a longtime IT nerd that likes to figure out all the complicated stuff and make it easy for other people to understand. This channel focuses on smart home tech and Home Assistant, so come with me on my journey as I endeavor to smartify all the things. Chances are, if you're watching this video, you likely already know what Home Assistant is. But for those of you that might still be doing some homework and haven't made the jump just yet, I'll give you guys a little primer. Many companies out there have their own little closed ecosystems. Things like Amazon's She Who Shan't Be Named, Samsung's Smart Things, Google Home, countless others. If you use one of those ecosystems, you need to look for the Works With logo on whatever device you're gonna buy. If the device is only compatible with Smart Things, for example, but not with Amazon, then you can't use it if you only use Amazon, and vice versa. There are many drawbacks to these types of closed ecosystems. Many of these systems rely on the internet, so no internet, no control. Many of them rely on cloud services. So if the company providing that cloud service decides to discontinue the service, or worst case, shuts down altogether, can you say Insteon? Your devices are orphaned. Those cloud systems can be vulnerable to hackers or other forms of attack, which can also impact your ability to manage your smart house. What does any of this have to do with Home Assistant? I'm glad you asked. Home Assistant is an open source, cross-platform, smart device management and automation solution. It runs locally on your network and can be directly connected to the things that are on your network. That means that for most devices, it does not rely on the internet or the cloud. There's no real concern about some service shutting down and causing you to lose control of your devices. Home Assistant has many built-in controllers called integrations to interface with and manage the various types of devices available on the market. These different devices may use various methods of communication called protocols, such as Bluetooth or Wi-Fi or Z-Wave or Zigbee, etc. If you'd like to learn more about some of these protocols, I'll leave a link in the description to a video I recently made on Z-Wave and Zigbee. But these devices, once connected to Home Assistant via their respective integrations, can then be centrally managed from one single system. This allows for the blending of devices across what would otherwise be separate closed ecosystems so that you can make your devices and your home do exactly what you want when you want it. Now, if you're feeling froggy and a device you want to use doesn't have an integration, you can always write one yourself. That's the beauty of open source. Good luck trying to write code by yourself to make something work with Amazon. Now, many of these closed systems do have integrations into Home Assistant so that you can expose the devices from Smart Things or Amazon to your Home Assistant installation. But really, that's just adding another layer of complexity. The devices will be managed by the controller from their ecosystem, and then you link that controller to a Home Assistant, and that controller then acts as a proxy to make those devices available to Home Assistant. Sounds neat, right? Sure. Until the controller breaks or goes offline and now half the devices in your house are unavailable to Home Assistant. Imagine if you had an automation that opened the garage door and unlocked the door from the garage to the house when you got home and then turned on a bunch of lights. It wouldn't be half as useful if one day the lights turned on but the garage door didn't open and the interior door didn't unlock. So what does all this have to do with the types of installations that are available? Well, in order to interface with these various devices out there using different protocols, you're going to need to add various bits of hardware to your Home Assistant server. You may need to add Bluetooth or Zigbee or Z-Wave or Thread or Matter. Each of these things requires the addition of hardware. In the interest of time, I'm going to try not to get too deep into the weeds on any particular technology discussed here. This video is meant to be more of an overview, not an in-depth technical how-to. Essentially, there are 4 different types of installation available for Home Assistant. Home Assistant Operating System, Home Assistant Container, Home Assistant Supervised, and Home Assistant Core. We'll start at the top. Home Assistant operating system is a minimal operating system that is optimized to run Home Assistant. It comes with the Home Assistant Supervisor to manage Home Assistant Core, as well as add-ons. This is the recommended installation method, and I'd venture to say is likely the most common method as well. HAOS runs directly on x86 hardware, like the Intel NUC that I installed it on in a previous video, but it can also run directly on Raspberry Pis. Many Raspberry Pi devices are available with HAOS preloaded, such as Home Assistant Blue, Home Assistant Amber or Yellow, and some Odroids too. Home Assistant Container is a standalone container-based deployment of Home Assistant Core. There are many different ways to run Docker containers, including on top of a hypervisor like VMware vSphere, or using Docker for Windows or Linux. Home Assistant Supervised is a manual installation of the supervisor onto an operating system other than Home Assistant operating system. This is an advanced installation type, and to be honest, I really don't see a ton of benefit here, but that could be specific to my current usage and the types of systems I have at my house. I guess maybe if you already had a bunch of Red Hat or Debian boxes running in the basement, maybe this would be something you'd choose. Lastly, we've got Home Assistant Core. Home Assistant Core allows you to just run the Home Assistant instance by itself, but it is a completely manual installation that requires using Python virtual environment. Again, not something I see a ton of value in for me. Before we continue, I'll say that my preferred method is HAOS. Of the methods on the list that we just covered, that one makes life easiest. Again, for me. Here's a handy little chart from the Home Assistant documentation that shows the high-level differences between the 4 different deployment types. This is very informative, and we'll look through it, but it does omit a few points that I think beginners should be informed of prior to making a decision. All deployment methods allow for automations as well as dashboards, so we'll cross those 2 off the list right away. All deployment methods allow integrations, so let's... Whoa, all right, not so fast. Yeah, they all allow integrations, but remember what I said earlier about how you might need hardware? In order to interface with these various devices out there using different protocols, you're going to need to add various bits of hardware to your Home Assistant server. Okay, so why is this important? Well, if you're running Home Assistant OS directly on the hardware, or bare metal as us nerds refer to it, then that means it has direct access to and control of the hardware. It can see and control the USB ports on the system, so when you plug something into one of them, Home Assistant knows about it and can begin using it just like when you plug something into your PC. You don't have to think about what happens when you plug a USB thumb drive into your computer, right? You just plug it in, start copying data. If it's a device you're plugging in, you might have to load some drivers for it, but your computer still recognizes the device and asks for the drivers, right? Well, imagine if you plugged in a USB device and then you had to dig around in the control panel or registry and tell Windows what the hardware address was for the USB port that you just plugged the device into. Totally wrecks the play part of plug and play. Well, for any instances that are not running HAOS directly on bare metal, some type of configuration for that USB hardware is going to be required. Hypervisors such as Virtualbox, Proxmox, and VMware vSphere allow for what's called USB pass-through, where you can grant the VM access to the USB hardware. It's generally pretty easy to do from just a drop-down menu. Now, if you've deployed Home Assistant as a container, you can still pass in hardware, but it can be a bit more difficult depending on what type of system you're running Docker on. Before you start looking too far down your nose at containers though, keep this in mind. The actual running instance of Home Assistant that runs in an HAOS deployment, in fact runs as a container, but all the management of that container, including pass through the hardware, is handled automatically for you. Next up, blueprints. Yep, can do that anywhere. Uses container. We already discussed previously. All methods are going to run as a container, essentially, except core. There's simply the matter of how much work you want to have to do to manage that container and pass devices through into it. Supervisor. What is the Home Assistant Supervisor anyway? In a nutshell, it's a program that manages the behind-the-scenes stuff for a Home Assistant instance, like performing installations and updates of Home Assistant, any of the add-ons, the Home Assistant operating system, and also itself, of course. Add-ons, a big one. Take a look at that. Container and core deployments do not support add-ons. Does that mean you can't use add-ons? Well, yes and no. You can't just click add-ons in the interface and add one because you're missing the supervisor with both of those methods. And remember, supervisor is what's responsible for the installation and updates of add-ons. So in order to use an add-on, you'll need to go find it, download it, deploy it as another container, or run some similar service elsewhere that you can link Home Assistant to. So you can get the same net functionality, you just have to do it in a different way. The benefit of this is that the container version of HA is meant to be very lightweight and fast, so keeping add-ons out of it helps to maintain that level of performance. Backups can be done with any deployment method, though there are some technical and operational differences between the different methods, but that's a little too deep in the weeds for the time that we have available here in this video. Managed restore. This can be an important one depending. HAOS and supervised deployments fully support managed restore if that's the direction you want to go. More on that later. However, container and core deployments, if you want to restore, you have to use a tool that migrates your install to HAOS, or it's a completely manual DIY restore of the backup. Best of luck! Lastly, managed operating system. Of course, the only one of the four that has that is HAOS. If only one of the four methods support this, it must not be that big of a deal, right? On the contrary, it can be a huge positive. If we rewind back to Supervisor and review what I said there, it's a program that manages the behind-the-scenes stuff for a Home Assistant instance, like performing installations and updates of Home Assistant, any of the add-ons, the Home Assistant operating system, and also itself. This means that the supervisor can perform updates of the managed operating system for you. Otherwise, if you run a supervised installation, for example, on Linux, you are responsible for keeping the Linux operating system itself up to date. Now, that has its pluses and it has its minuses. On the plus side, you can use the Linux box for other things. On the minus side, you're using the Linux box for other things. But more on that in a minute. So far, we've covered the 4 different installation methods or deployment models. Now, let's take a look at the way that we can run them. So, of course, HAOS can be deployed bare metal for any system type there's an image for. A handful of these are, of course, Raspberry Pi and x86 PCs, but there are also images for Odroid as well as Asus Tinkerboard and several others. Check the Home Assistant website for a full list, or you can go and browse the GitHub repo. What are the pros of deploying bare metal? Home Assistant has the full resources of hardware available to itself exclusively. No fighting with other systems for processor cycles or for available RAM. Home Assistant also has direct access to the physical hardware, making adding USB devices fast and easy. HAOS will fully manage the deployment for you, including updates for all facets of the Home Assistant software stack, including HAOS, the supervisor, HA Core, add-ons, etc. It also allows for the reuse of nearly any old hardware that you have available, so this can be a great free way to get up and running. Cons? Home Assistant is unable to share any of the hardware resources with other systems. Since Home Assistant doesn't require a great deal of resources to run efficiently, this can be wasteful depending on the hardware you've chosen to run it on. Lower density can mean greater power consumption and in turn, greater heat generation. Bare metal systems like a Raspberry Pi are quite power efficient and they do run pretty cool, but consider what it would be like if you instead had decided to install HAOS onto your old gaming PC with 2 video cards and a 1000 watt power supply, and you get the idea. Backups are pretty easy, but restores are harder than they would be if you were running Home Assistant as a virtual machine. More on that later. Next up, let's discuss running as a virtual machine on a dedicated hypervisor, something like Proxmox or VMware vSphere. Now, a quick primer for those of you not familiar with virtual machines. A hypervisor such as Proxmox or vSphere is a purpose-built operating system whose sole function is to take large amounts of physical resources, primarily CPU, RAM, and storage, and divide it up into smaller pieces, essentially creating little virtual computers known as virtual machines. These virtual machines then share the physical resources of the hardware that they're running on, and You can even oversubscribe the hardware. The hell does oversubscribe mean? If you have a VM that requires 2 cores, and another VM that requires 2 cores, and a third VM that also requires 2 cores, you can run all 3 of those VMs on the same hardware, even if that hardware only has 4 physical cores available to it. Now, I know, my viewers are pretty smart. You're all sitting out there thinking, well, wait, 2 plus 2 plus 2 is 6. How are we going to run that on hardware that only has 4 cores available? Aha! Without virtualization, you'd have to buy 3 of that same system. But each operating system you installed on each of the physical systems would only consume 2 CPUs, but you'd have 12 in total, and that would leave you with 6 wasted CPU cores, but you paid to buy them and you're paying for the electricity to run them. And special considerations should be taken when oversubscribing physical hardware, but that's another video. First, the pros. VMs are essentially just virtualized x86 hardware, so you can still run HAOS for a fully supervised install and get all the benefits that come with that. Home Assistant is able to share physical hardware resources with other virtual machines, leading to increased efficiencies in terms of power consumption, rack space density, as well as storage. But again, that's all another video. Another benefit is increased uptime through the use of advanced configurations like shared storage, where you can perform vMotion. Snapshots can be used to ensure that you are able to very quickly and easily return to a prior state. This is especially useful in the case of a failed update, for example. So what's a snapshot? Easiest way to think of a snapshot is it's a picture of that VM at that exact point in time, and the hypervisor can use that picture to revert that VM backwards in time to that exact configuration, discarding any and all changes that were made between the time the snapshot was taken and the time when it was rolled back. So you take a snapshot before an upgrade goes pear-shaped, roll the VM back to the same operational state it was in prior to attempting the upgrade. Note that this does increase disk utilization, but that too is a different video. Migrating to new hardware with this method is very easy. The entire VM is just a series of files on disk. Did your server die and you bought a new one? Put the drives in the new server, mount the virtual disk files, away you go. But newer, better hardware you just want to migrate onto? Copy the files over. Now the cons. That oversubscription thing I mentioned previously, that can come back to bite you in the ass. If your hardware doesn't have enough physical capacity to process CPU instructions in real time for all the VMs running on it, the VMs will start to be paused until the scheduler in the hypervisor is able to free up physical resources to carry out the instructions that the VM needs to be carried out. Individually, these pauses aren't enough to really notice. The VM won't notice, you won't notice. However, collectively, they can be enough to diminish system performance by 5, 10, 20% or more. Now, another con is that you're gonna need to put in a little more work with physical USB devices like Zigbee or Z-Wave dongles or Bluetooth dongles, that kind of thing. Since the virtual machines don't have direct access to or control over the hardware, they won't know you've plugged something in until you manually go in and configure them to use that USB port and the device that you plugged into it. You're gonna need to learn a lot about the hypervisor, how to install it, how to maintain it, how to upgrade it. You may need to buy specialized hardware, especially in the case of vSphere, or you may need to be comfortable hacking together a solution that's unsupported. An old coworker I once knew was able to get vSphere running on his Nook. Totally not supported hardware. In many cases though, people will buy used servers. And when I say server, I mean legitimate server hardware, like an HP DL380, a Dell R550, IBM X3650, a Cisco C240, not servers like people assemble in their basement and refer to as a server. Such industry standard server hardware can be had relatively inexpensively on eBay or used from hardware resellers online, but this hardware was designed for high performance computing and to be used in a data center. So things like heat, noise, and power consumption were not top of the list when they designed this hardware. Many of these systems have 8, 10, 12, even more fans in them, so they're very loud, and they have redundant power supplies in excess of 1,000 watts apiece. In addition, They take very specific types of system memory that cost far more than just ordering a few DIMMs from Amazon, and they typically require special types of mounting hardware for the storage drives. Not to mention, they may even require drives with a special interface type that costs far more than consumer-grade drives. However, this hardware was designed to be a workhorse, so you can expect to get many years of trouble-free service out of it in most cases. If you can get the hardware for free or extremely cheap, and you don't care about your electric bill or the noise level, this can be a great way to go. Next, let's spend just a minute discussing running Home Assistant as a VM on your Windows desktop. I mean, I've made 2 different videos about how to do it, both on Windows 10 and Windows 11, and I've taken a lot of shit from people over them. So it's not like I can just omit this option, right? Pros. You probably already have a Windows desktop, so it's not gonna cost you anything. Virtualbox is free. Depending on your edition of Windows, you may even have access to Hyper-V as well. It's very fast and easy to get it set up. It's great for a lab environment or when you just want to test something out without possibly messing up your production Home Assistant server. Cons. It's running on a Windows desktop. I mean, Windows needs updates. It does them automatically. It just reboots whenever the hell it feels like it. So if you're running your main Home Assistant server as a VM on Windows, you should count on it being unavailable at times until you go answer all the obnoxious prompts from the latest Windows update about whether or not you want to sign up for Office or upgrade from Windows 10 to Windows 11, or if you want to turn on personalized advertisements or sign up for games or any of the other crap that they throw at you during that process. Now, those are going to be the big ways that most people run Home Assistant. But what about Raspberry Pi? That's just a bare metal install onto different hardware, and we've already discussed the pros and cons of bare metal. But what about containers? Containers are essentially virtualized environments that contain all of the code necessary to run the application that you want. We already talked at a high level about virtual machines, but now, for the most popular question that I seem to get, PC or Raspberry Pi? The answer really is, it depends. Now I know, any of you out there that have ever dealt with a consulting company, that's the consultant's favorite answer, right? It depends. But it's true. Allow me to explain. The first thing you need to figure out is, do you already have hardware available for either one of those install methods, or would you have to buy whichever one it was that you chose? I mean, if you've already got an old PC, then definitely go install on that, since it won't cost you anything except time and electricity. But if you've got neither one, listen on. Now, I ran my production Home Assistant server on a Home Assistant Blue for the better part of 2 years. It ran great. It was quiet, it wasn't hot, didn't consume much power. When I wanted to add Zigbee, I just plugged in a dongle and away I went. It was awesome. But in the back of my mind, the fact that I was running on an SD card or even eMMC, it always just kind of nagged at me, tugged at me. SD and eMMC just isn't as reliable as SSD. I mean, they just don't have the read-write duty cycle rating. Now, don't get me wrong, you might be able to run for years using that. And I could have too. I mean, to be fair, mine didn't fail. But being the IT professional that I am, it just bugged me. But that's still not what pushed me over the edge. So what finally pushed me to moving my system to run bare metal on a NUC? Performance. The more add-ons that I added, the more complex that my dashboard got, the more automations that I configured, my system just got progressively slower and slower and slower. And when I'm saying I added a lot of stuff, here's a screen grab from my Home Assistant server. I know it's kind of small, and some of you might be watching on a phone, so I'll hit the high points for you. 110 automations, 143 binary sensors, 23 cameras, 140 device trackers, 16 lights, 29 media players, 398 sensors, 203 switches, and 25 zones. That's a lot of stuff to ask a little old Raspberry Pi to keep track of for you, so I can understand why it got to be a bit overwhelmed. And that's not to mention that almost every card on every page of my dashboard has conditional logic in it to change the icon and or the icon color based on the state of something else. So the simple act of loading the first page of the dashboard causes dozens of sensors to be checked, logic to be run through, and changes to be made on the fly. It was this that caused me to notice the eventual shortcomings of the hardware that I was running on. It was the slowness of the dashboard. If you're just getting started and you've got a Raspberry Pi, or you can find one for cheap, or better yet, if you can buy a preloaded system for cheap, like an Odroid N2 or an ACA Blue, Amber, or Yellow, do it. They work great, and you'll get years of faithful service out of them. Later though, if you fall down the rabbit hole like I did, you can always upgrade and move to more powerful hardware at that time. I think that's enough for one day, don't you? I'm sure this has given you a lot to think about. I feel like some of this stuff really only scratched the surface though. Let me know in the comments if you've still got any questions or if you'd like additional information on any of these topics. In any event, I hope that you liked the video. I hope that you like the way that I present content. I hope that you found the video informative, and I hope that you found this episode's t-shirt humorous. I sure like this one. My day job, they don't like it so much, but I think it's hilarious. I hope that I've earned your subscription, so if I did, please go ahead and give that a smack, and don't forget to tickle that bell if you want to be notified when I publish new content. Thank you so much for watching, and until next time, go automate something, will ya?